Okay, well, hello and good morning and happy Monday, week 4. We are moving right along, and so this lecture is going to focus on getting your data into R. So, well, I guess maybe I should just say a couple more things. So, again, I want to give you the freedom to select your own groups, and so if you have a group established, go to the group sign up sheet, put your names in, and maybe you found just one other person so far that you want to work with. You can just put you can put your 2 names in, and you can say we're looking for more groups or more team members and things like that, and whatnot. Again, I'll give you guys until Wednesday 11:59, and then after which, probably on Thursday I'll go through and I'll just assign everybody else to a group. But yeah, there's no promise or guarantee that the people that I assign you will be a good match or something. So just want to do that. Okay. And then once you have a group established, you should start meeting and just start talking about data that you're interested in, data that because the first part is you're going to have to look for data. Okay, you're going to have to look for some kind of data, and we want it to be a data set that you are interested in, where you can kind of either, if you have background knowledge, that's great, okay, about the data, that's great. If you don't, that's also okay, but you have to be kind of willing to look into it and look into understanding these numbers and perhaps checking other sources. And it's just going to be much better if it's a subject that you're kind of interested in versus something that means nothing to you, okay? But yeah, a big part of this kind of early phase of just is this data set going to even work for us, is first you got to get it into R to start kind of taking a look at it. And there are quite possibly different issues that you might run into just getting your data into R. And so I wanted to spend some time talking about that today. Okay, so some recommended reading is in R for Data Science. There's a chapter on importing data, and then there's another one of the packages that is really good at importing data is the readr package, okay, and that's part of the tidyverse, and you can read the documentation there. Okay, so I'm going to cover a few different packages that are useful for importing data, different forms of data. Probably kind of the most common form out there is the comma separated values, but there's also data coming in lots of different forms and elements. And I think you guys know how to install packages, but I want to just kind of reiterate a couple things about installing packages. It's like buying a cookbook, okay? So you can think of the package as having kind of these functions or these recipes that you can use and load up, okay? And so, but you have to kind of install it first. And that part is like purchasing the cookbook, but you only need to do that once, okay? And you do that by running install.packages this, install it just once. Do not include that line install.packages in your RMD file, because that's going to trigger a reinstallation of the package every single time you knit the document, and that's going to just really slow things down. And it's just a waste of downloading your bandwidth and put strain on the servers and things like that. Okay. Sometimes when you install a package, a little thing will pop up, or a little question will appear in the console, and it will ask you, do you want to install from sources and compile? Okay. And we're accustomed to just answering yes to everything, but this is one where you want to say no. Okay. Unless you're familiar with compiling, code and creating your own binary executables and stuff like that. I just recommend no. No is going to just install the latest binary executable, which just simplifies your life. It might not be the latest version. So usually the way these packages are released, you'll get like the source code that requires compilation that gets posted first, and then the binary executable comes out a little bit later. And so it'll be like, oh, here's the latest version. Do you want the absolute latest version? But you got to like compile it yourself. And just to avoid headaches, just say no. Just say, I'm okay with the second, most recent version that has the binary executable. So choose no if that pops up. Okay. Another method is to use like the features within RStudio, and there's this over here. There's the packages pane. Here, let me clear out all of this stuff here. And you can just click install here, and you just type in the name of the thing. Like if you say I want to do like the tidyverse, okay, you can type in tidyverse and you can click install. Okay. All right. So it says, do you want to restart? So I'll click restart. But anyway, it will. It's running here, and RTools is required to build packages. Yeah, that's fine. Okay. All right. So it says that, and then that's it. You can install your packages that way. You can also update your packages. You can click update here, and it will search and say like, oh, these packages can be updated. Well, it looks like I've got a lot of packages that can be updated, right? And so you can select this and just say like, oh, I want to install an update, and it will update your packages that way. So this is the package manager down here is also a handy way to install packages. Okay, and really all it does is that when I type in install here and I type in tidyverse, all it's really doing is it's just putting the code into the console for me and then running it. Okay, so this is just kind of a like if you don't want to think about what code I have to write, but basically all it did was type in install that package as tidyverse for me when I said I want to do install, this package. Okay. Okay, but anyway, the package we're going to use to load our data is going to be readr. Okay, and this allows you to read in basically text files. Probably the most common will be the comma separated values, CSV, but there's also other things, TSVs, tab separated and delimited and fixed width files and things like that. There is a cheat sheet available here that provides a quick reference. Actually, let's go ahead and visit that now. And so, so this cheat sheet, covers a lot of kind of, if your data comes in looking like this and you want to import it, this is how you would go about it. And then you can specify, different kind of options and features there, right? Depending on what you're dealing with, you might have data coming in from other software packages or software, statistical software. So SAS still is popular like in government settings, and so certain websites will post their data in SAS format. SPSS and Stata is probably less common for publicly posted data, but you might encounter it. You might know somebody from another department and they might have data in these forms, and to kind of get these forms into R, you'll want to use Library Haven. But if you're not dealing with any of these things, you don't need Haven at all. Okay. Also, if you want to read data in from Microsoft Excel, you'll need a package read Excel, and basically you just call read_Excel and put in the name of your file. Excel, those files are called workbooks, and each workbook can consist of one or multiple worksheets, basically multiple spreadsheets. And so if you want to import a particular spreadsheet, you can import it by name or by number and say, I want to import the second spreadsheet or something like that. Okay. And so that's package read Excel. Okay.
Do the sheets index from 0 or 1?
1. And everything in R indexes from 1 in general. Yeah. Okay. All right. And then data.table is for large files. So if you have a big data file, like over a gigabyte, okay, then data.table will offer faster performance, and so that would be what I recommend. Okay, and then again, there's no restriction. You're allowed to work with big data files. Just there are certain challenges that come with that, and that like generally any kind of operation that you want to do is just going to take a few seconds to possibly a couple minutes to operate on your computer. So it just kind of slows down your analysis a little bit. But you might find something really fun and exciting in some kind of big data file. But again, you're not required to, and there's no bonus for doing big data files. So, but that's it. Yeah, question.
When we're reading, for example, a CSV file,
yeah,
do we need to make sure that the RMD file and the CSV data file is in the same, for example, desktop folder?
Yeah, it should be. You want to have basically all of the files that belong to a project in the same folder. So, okay. So yeah. One thing you want to avoid is just leaving everything in your downloads folder, okay? Because your downloads folder probably has like 1,000 folder files already in there, okay? And it just gets really messy. So at the very least, create a folder inside your downloads folder, or create a folder on your desktop, or a folder somewhere, and call it your lab, and then put all of the relevant files together in there. Yes. Okay. And then there's package downloader, okay? And sometimes you may want your R script to download a data file directly from the internet. And the reason why you might want to do this is that, if you share script files from yourself to another, a teammate or something, okay, you don't want to have to be like, okay, you have to go to this website and download this file, all right? If you have the URL of the file to download, you can just put that URL directly in your script, and then in your script call the command download this file, all right? And then you'll say, download the file and save it here, and it will run on whoever else's computer. So it makes this this aspect reproducible and simple, so you can call download. And so to do that, you'll need to install this library downloader, and then you'll provide it the URL where you're going to save it. And then once you have it saved, so the default location for saving is wherever your current script is located. So if you have an RMD file and you put your script in there, when you open that RMD file, R defaults to whatever folder that's in will be its kind of save location. Okay, things do get a little bit weird if you like open R from one file and then you switch over to another file. Its default save location will be like the first file that you opened. So you might want to just like restart R after opening up the current file that you're working on. Okay. You can also save and export data, and this is these are the commands that you would run to save. And so if you want to save multiple objects in kind of the native R data format, you name the different objects, and so these could be data frames or vectors or whatever it is, and then you'll say, I want to save it into this file. You can take, if you have a vector of values and you want to save that to a text file, you can do that. And if you have data frames, you can also save those to like CSV files. Okay, and then within RStudio as well, as you kind of work in your thing, and if you create some vector, I'm going to just create the values 1 through 100 or something like that. Okay, you can take, you can save your workspace for later, and I think, let me see. Yeah, no, I guess just save that. Yeah. Okay. So you can you can just save your current workspace, or you can load up, workspace with files that you've or objects that you've saved and exported. Okay, there is another package that I strongly recommend for everybody to use, especially if your data has any kind of date information. And so working with dates and times in R, and actually any language really, is really tedious, okay? Here's a question, okay? So as you think about variables, we have numeric variables and we have categorical variables. And categories tell us what type or what kind, and numeric variables tell us a quantity, okay? So this is kind of like an aside. So, a lot of things we just think of like, okay, numeric variable, like height and weight, that's numeric, that's a quantity. You weigh 120 pounds, this person weighs 125 pounds, there's a 5-pound difference between these two people, okay? And you can kind of compare quantities or numbers that way. If you can't compare the numbers and say like this is 5 pounds higher, or this person is 7 years older than another person or whatever like that, then it's not going to be a numeric quantity. So things like area code and zip code, even though they look like numbers, they are not numeric variables. So if I say I have area code 213 and this person has area code 310, you don't say this person has more area code than the other person. That kind of numeric comparison doesn't make sense. So you don't, so that is not numeric, okay? And even the way we read an area code, we don't say it's area code 213 and area code 310, because then you could do like a subtraction and say like there's a 97-point difference, but that again doesn't make sense. But if you can make a comparison and say this is higher than the other, then it's going to be numeric, okay? So with that in mind, is a date numeric or categorical? Like if we say today is April 21st, 2025. And another month, 30 days ago, would it be, I don't know, March 22nd, 2025? Is that a numeric or categorical variable? It feels like it's categorical because we have words like March and April, but the fact that I can say 30 days ago was a different day, right? And 20 days from now is something else, and you can take two dates and you can calculate a time difference between them. Dates are numeric, okay? It's weird. They're formatted in the most bizarre way that has evolved over, I don't know. And it's a miracle that the whole world is using the same calendar. That doesn't make sense at all, right? Like we've got 31 days in January and 28 days in February, and where did these names even come from? There's history and stuff, but it is a numeric variable, and we just pick an arbitrary point in time and say this was year 0, and it's been 2020. And there's actually no year 0. Year 1, and it's been 2024 years since then, or I don't know, and then we can do numeric comparison. So date is numeric, as weird as it seems. Okay, but anyway, because dates are formatted so weird, dealing with them is a pain. All right, so if you wanted to just use base R. And this is like a thing that exists. This date stuff like is kind of like this universal thing, and like even with like Python and dealing with dates in Python is such a pain. This is painful. Okay, if you have like the date January 15th, 1999. Okay, and you try to make it as date, you have to have the format string exactly right. Otherwise, it doesn't work, and you get an NA. And if things aren't perfect, you get NAs. And if you have a mix of formats, like if you had somebody fill out a form and somebody typed in their date this way and somebody typed in their date this way and somebody else typed in their date this way, like R just can't handle this. So it's very kind of painful, okay? But if you have package lubridate, okay, and the dates came in like this, right? You had a form and people typed in their birthdays or whatever, okay? You can just say, hey, take these dates, which are currently just character strings, and parse them as month, day, year. And R figures it out and says, oh, okay, this is the date, 1999-01-15. This is the date, 2001-12-15. This is the date, 2002-03-18, and so on and so forth. And this works, okay? So you have functions like month, day, year, month, year, month, day, and that's going to kind of guess the correct format based on the order you specify. Now, the one requirement is that all the dates have to be in the same field order. So, like, if you have an American person typing in their date and they say, my birthday is, 07, 08, 2003, okay? An American would translate that as July 8th, right? But if it's a European and they type in 07, 08, 03, that would be August 7th, okay? And you can't mix kind of this, lubridate can't figure that part out, okay? So you have to do that, all right? Oh, so here is an ambiguous date. If you have 03, 04, 05, is that year, month, day? Is that month, day, year? Is that day, month, year? And it will, whatever you tell it, if you say this is month, day, year, this is March 4th, 2005, then it will figure that out. But if you say, oh, it's actually day, month, year, like you're from Europe or something, then that would be something else, okay? And if you give it something that it can't understand, like 2512, and you say that's month, day rather than day, month, it'll just say like I couldn't parse that. Okay, but anyway, if you're dealing with dates, use lubridate. That is my recommendation. All right. Have I given you any answers yet for your word quiz? Okay. First answer today is A as in apple. A as in apple. Okay. So let's talk about importing our data. Okay. So here is an example data set, okay? This is a fake CSV file, or I don't know, I guess a real CSV file. And you can download this from, I think it's posted on Brew and Learn as well. It's also available online. And this thing has some issues, okay? We have some missing values. We have an NA here, N/A. We also have a blank after lunch only. There's nothing. We have inconsistent, so age. We have 4, 5, 7, and then somebody typed in FIVE. Our column names have spaces in them, so some problems. But anyway, if you have it stored as a CSV file, you can call read_CSV. Basically the name of the file. Now, default show column types is true, and it just gives you some information immediately after you imported it, and that's not a bad thing. I have it disabled because it would kind of blow out the slide, and I wouldn't be able to show you stuff. But anyway, we use read_CSV to do this, okay? And once you have that, so make sure you call read_CSV, and then you use this arrow to assign it to an object name. So here I'm going to call this the object students, and then I can refer back to this data frame, or in our case a tibble, okay, called students. And then so now to take a look at it, I can say print students, and this is going to print out the data in this table form. And it's the exact same information that was in our comma separated values file, and it's done like this, okay? So this must be Australia or something where they have things spelled out differently, right? Yogurt and favorite. Okay, but that's fine. All right, so this is the resulting table or tibble. This is which is what the tidyverse calls their data frames, or tibbles. So this is what we get, and we can see, because student ID has a space, it has to get surrounded by backticks, right? And so we have a few things to do, okay? You can also, the data file is available directly online as this CSV file. And sometimes, if you have data that's hosted online and it's no trouble to download it, you can just put in the name, the URL of the data file in there, and read_CSV will import it as well. Okay, and so this gets imported there. Okay, another way to import your data is in RStudio. You can use the Import Dataset button right here. So you can click Import Dataset. You would then choose from text, readr, or I guess from any of these other files if you need to. Okay, and then so you'll click from text, and then you can either paste in the URL. So in our case, yeah, I can just paste in this URL and get rid of the things here. Okay, so I'm putting that in. I'm going to click Update here, and it's retrieving the preview data. Let's see. Oh. Okay, I can't see it. Oh man. All right, I think I have my screen magnified too big. But anyway, normally you can kind of see a preview of the data, and you can see how it's going to, the names and the data types and all kinds of stuff here. And you can title what it is you want. And we're going to call this thing students. And then you have different options. First row is names. Yes, we want that. Trim the spaces, open the data viewer, sure. Okay, and we can do that, and we can just click import, right? And then it shows us the data that we imported here. All right, so that's another option, is to use the import data set, and again, use readr rather than base. Okay, readr is going to give you better performance there. Okay, so it's in that location there. All right, so here's the little preview there. Okay, so this is what our data looks like. If I call print students here, so you can see it here. You can also click the data file or the data frame in the environment, and it brings it up here as well. Okay, and we could see we have actual missing values, which R has detected and has written as NA here. Okay, and then if I, in the print version down here, it shows up over here as a missing file. However, in our when we imported it, there was also somebody who typed in n/a. Okay, and so this is a missing thing, meaning we don't know what Jayendra's favorite food is. Okay, but rather than going in as missing, now we have n/a as written as their favorite food. So in order to kind of, so you can see it appears here, whereas actual missing values appear kind of like this, either in the red text or with the kind of the brackets there to indicate that it's recognized as missing. What we can do is we could say anytime you encounter, and then you have to specifically say what it is, all right? So it might be n/a. In some text files, it might be like, if you see the number 999, that means the value is missing, right? So if it's like age, you'll have someone's age, but then some people's age might be coded as 999, and that just means the person's age is missing or something. So you can put in what are the values that should get counted as NA, right? You can also put in empty cells or whatever, probably leave that in there, and so on. And then so now that gets fixed, and the NAs appear like that, okay? The column names, we don't like having spaces in the column names. So to fix that, so here I'll just run each of these lines in R here. And just delete this out, close this off. All right. Choose directory. All right, so this is with the NAs, so I can open this and now we can see that that has been fixed. So these are NAs, but again, I still don't like these column names. So to fix that, I'm going to run this operation rename, okay? And so notice I'm using the pipe. I'm gonna read in the CSV file, and then I'm going to take the output and then call rename on it. Okay, and what rename will do is I provide the name I want to use, in our case student ID, and we're going to replace backticks student space ID with student underscore ID. I'm going to use backticks full space name with full underscore name. And so if I run this, so this is currently what my thing looks like, I can run this command where I'm going to read in the file and then replace the names. Rename. Oh, I did a little tidyverse. Okay. Okay, and then so now my columns have been renamed, okay, to have underscores. And this just makes it easier because then you don't have to use backticks every time you refer to a name. Okay, so now you can just call student underscore ID, full underscore name, things like that. Okay, there is a package called Janitor, and this automatically does some cleaning of data files, right? And so what this will do is it converts names to lowercase, replaces spaces with underscores, removes any kind of special characters. So there's a couple things here like favorite dot food, meal capital plan, all caps age, and when you run Janitor clean names, it will go through and fix all of these up into basically names that are a little bit more friendly, because all caps, I don't know, for whatever reason it's frowned upon. Okay, at least in the R style guide. Other languages, SQL and things like that, it's not an unusual thing. Okay. But anyway, and that's done automatically by just calling clean underscore names. So here we can read in the CSV file and then pipe that into clean names, and then that works. Okay, but that comes in library Janitor, so you have to load that library up. You have to install it if you don't already have it. And I don't think I've installed it over here. I have it on my home computer, but not here. So I can just call Janitor right here. We'll install it, and then it runs there, and then we'll so I'll call library Janitor to load it up, and then we'll read in the file, and we'll call clean underscore names. Okay, and then so that has gone through and it has cleaned the names, which we like. Okay, and so again, this is just tips to kind of make your life easier as you're doing things. All right, there's a few things. So by default, you'll notice that when you import your data and you view it and things like that, R takes a look and sees the things, and if it's all numbers, it will say, okay, we got a numeric column or type double. That's another way of saying numeric values. Okay, and if it sees kind of character information, right, like the name, then it'll say this is character. Okay, favorite food, character. Okay, meal plan. Here our choices are lunch only, breakfast and lunch, lunch only. I guess those are my only choices. Maybe there's a breakfast only option. I don't know. Regarding, I'm assuming this is like public school meal plans and stuff. Okay. If it's kind of like, imagine, having a form that somebody could fill out online, and you might want to have, on some of the things, you might want to just give them a drop down, okay, a drop down of choices rather than type in whatever you want, right? So favorite food, you can type in whatever you want. But if it's kind of like, which meal plan are you on, there might be just a drop down, okay? And so as far as that goes, if it's basically a list of, select options only, you might want to call that a factor, okay? And a factor is basically how R represents categorical variables with just limited or a known set of possible values, okay? And so here we're going to just convert meal plan into the factor version of meal plan. So all we're going to just do is take meal plan as it exists, wrap it in factor, okay, and then call it back into meal plan, all right? And so whenever you change a variable or create a new variable, you put it inside the operation mutate, okay? So mutate either creates a new variable or it changes an existing variable. And you give it the name of the variable that you want to create, or you give it the name of an existing variable, like meal plan, and it will replace the existing variable. So here we're going to replace the existing variable of meal plan with the factor version of meal plan. And all that does, it's a subtle change, okay? But in the previous version, I could go in and I could change my data, and I could say, oh, okay, someone wants to, and then instead of doing lunch only, I could just type in some gibberish there, and then R would allow it, just because it's just characters. It's kind of like, it treats it kind of like a name field where you could type in whatever you want, okay? When it's a factor, then only basically certain options, and in this case, lunch only and breakfast and lunch are the only options available to us. And if I want to have a third option, say dinner or something like that, I would have to manually go in and tell the factor that this is now an option, an available option. There's factors have what's called levels, and it lists off basically the different choices available. But we won't worry about that just yet. Okay. All right. There's one more issue, and that is, in this age column, probably it should be a number, right? It should just be, all right, this person's 4, 5, 7 as a number, and we just want to be able to subtract these. But somebody had to be creative and type in FIVE, okay? And that has basically forced this entire column of age to be treated as characters, okay? And so now that it's treated as characters, it's no real different than full name or favorite food, where somebody can just type in whatever they want. Okay, and so what we want to do is we want to kind of force this to be numbers, okay? And so we have a couple choices, okay? All right, and so here we wrote, sometimes read_CSV will parse a column as character if it detects inconsistent data types, like mixing numbers with words, which is what happened here, okay? And so parse number is a function when the column should just be numeric. Some entries are characters, and you just want to kind of drop them, okay? So if you just want to get rid and just say, like, okay, you typed this in wrong, we're just going to throw away this value, okay? You can do that, and you can just do parse_number, and that's just going to force everything to be numeric, okay? So that row got kind of messed up here, but basically this student who was whose favorite food was pizza and age was spelled out now shows up as NA. So this just kind of converts everything, and it basically says, and it says, hey, you know what? Just a warning. When we said parse number, I had a parsing failure, and it was, row number 5. We were expecting an actual number, but what we actually got was spelled out FIVE, so we just dropped it, okay? So it gives you a kind of a heads up, like, just so you know, we threw out some data, okay? You might want to say, well, you know what? Sometimes people do spell out their words or spell out their numbers, and so you can run something called case one. Now, this is a little bit more annoying. This is more like a manual kind of going through and fixing things. But basically, here we're going to say, take age and then case when, and if age is, if you see FOUR spelled, that should be replaced with the number 4. If you see FIVE spelled, that should be replaced with the number 5, and so on and so forth. With case when, basically the form of case when is you have a condition tilde result, okay? And the condition is basically if you see this equal to this, right? If the age is equal to this, replace it with this thing, right? So that's what we have going on with case when. You always need to have a default, okay? And that's going to be case when true. So in our case, true is just going to be take whatever age is, make it numeric, and that's basically like if you see the number 7 already as the number 7, just put it in as numeric number 7, okay? And that's what we have. It says, we did have an NA, and there is still an NA, but basically it converted that FIVE using our case when. It saw the 5 FIVE and replaced it with numeric value 5 here. So that's another possible an option. But again, depending on how big your data set is and depending on how many kind of special entries you have to enter, this can become tedious. Yeah, question.
For when you do case when and you did that age equals 5, is it allowed to only just do that one, or do you have to have age equals 4, age equals 6?
Yeah. I didn't have to do age equals 6 or age equals 7 because that never actually appeared in our data. Okay, so the ones for the 4, 6, and 7 were unnecessary. I guess I was just kind of like imagining in a generalized thing where we're gathering information about these primary school children or something in their meal plans. We might have encountered more of these things. Okay, but yeah, I suppose somebody, I don't know, types out the thing in Spanish, and then do I want to have to consider those possible cases, or is there a point where I'm going to just, or maybe somebody misspelled 4 to FOR, and do I want to consider that, and then it's like, how many cases do I have to consider? So it can become tedious. Again, these are some of the things you might face when you have thousands and thousands and thousands of entries. Yeah.
And if you do the age equals 4, if they do a capital, some person did a capital.
Yeah. You would have to have a separate thing. Yeah, if it's capital FOUR, that's different from lowercase FOUR. So yes, it does become annoying very quick.
Is there no method in OR to basically strip the case from everything so it's
Yes, there are ways to just strip the case. Yes, so you can with mutate and things like that. So you can do kind of a pre-processing thing where you can just say age is going to be lower. I think it's just 2 lower, okay, or and it's just going to turn everything lowercase, or 2 upper and it turns everything uppercase. So you can do that. Yeah, so you can say okay, I have to deal with this. People have capitalized, people have doesn't. So you can say, I'm going to do 2 lower and then case when age equals 4 and stuff like that. It's a little bit beyond the scope of the course, but there's a lot of kind of powerful text processing methods with regular expressions. But again, that's a little bit beyond the scope of this course. But yeah, there's lots of things, okay? These are all just different options that you can do, okay? And then anytime after you import your data into R, you should always just double check to make sure it imported correctly. So always just kind of click the thing and you can view it, okay? And kind of scroll through and make sure everything looks right. Or there's a few other things you can do. Head or str structure will give you kind of like a sense of what the data types are, okay? What are the different data types in your thing? There's also glimpse, which does something similar. Okay, and it gives you kind of the different information that it shows up in there, and you should kind of do. And you should always just kind of ask yourself these things: are the column names what you expect? Are the data types correct? missing values, and so on and so forth. Okay. Oh, we're gonna run out of time. Let me give you your second and third view quiz answers. Second answer is C, C as in cat. And your third answer is E, E as in elephant. So C as in cat and E as an elephant. Okay, so once you have your data in R as say a tibble, okay, sometimes you want a subset, okay, and you just want to select a specific row or a specific column or a specific range of values, okay? So one is you can pipe it into a function called slice, and you just put in what row you want to select. So you can say slice out row number 2, okay? R also offers bracket notation, and with the square bracket notation, you basically put in, you can put in 2 numbers here. The number before the comma is which row you want, and the number after the comma is going to be which column you want. So here, if we're selecting the second row, I would say students square bracket 2, comma, and that would basically pick out the second row, okay? If you want to select multiple rows, you can put in, you can give slice basically a little vector of values, and you say I want row 3 and then row 2, and it will give you row 3 and row 2. Same thing with the square brackets, you can just put in square bracket, I want row 3 and row 2, and it will give you those rows, okay? There's a difference if you slice and you select like rows 4 through 8, and our table only had up to row 6, slice is not going to give you anything else. Whereas if you do square brackets and you say I want rows 4 through 8, it'll give you 4, 5, 6, and then it'll just give you all NAs for row 7 and row 8 here. So there is a subtle difference here, but that's what you get. Okay. Selecting a column is done with select. So slice will select the rows, select will select your columns, okay? And with square bracket notation, you put the column you want after the comma, okay? So here, if you want the second column is the name of the student, so you can just do square bracket comma 2, or pipe it into select the second column, okay? Again, you can do a range. You can say I want columns 2 and 3, or I want columns 2 and 3. And then you can select coordinates. So you can say, I want the second row, third column. And that's going to be done with square brackets. I want the second row, third column. You could do it this way as well. You can say, select the third column, slice out the second value, or slice the second value and select the third column. That's also fine, okay? And then sometimes you don't want the full column as it, like when we selected the column here, it gives you a tibble with 1 column in it, but sometimes you just want that vector, okay? And so there's a few different ways to do it, okay? You can use double square brackets, will extract the vector, $ notation will extract the vector, and then pull will also extract out a vector, okay? So if you just want the vector of names, you can do double square bracket 2, and that will give you the second column as a vector of names, okay? And if you just want the third value in there, you can do double square bracket 2 and then single square bracket 3 to get the third thing, okay? Here the column name is called full name, and so we can do $, and we'll give it the name of the column, and now again extracts out the column as a vector, versus if you do select, it always returns it as a table form, tibble form. Okay, and then so $ notation will work as well, and then you can also do select to select the column, and then pull, and pull will extract it out as a vector. So these are just different options for getting the data into a vector once you have a tibble in R. Okay, all right. Form your groups and just start exploring and start looking up possibly interesting data sets that you're interested in, and then yeah, discuss with your group what kind of data you want to investigate.